All right, everyone. Thanks for joining us today. I'm going to be taking us through some of our day 3 examples for graphing our higher degree polynomial functions. We're going to talk about a quick review and then sketch 2 functions. You don't need a note sheet today. You can follow along with the video and then sketch the graphs on paper. The nice part about these problems is as long as you have a piece of paper, you can do anything that we are asking you to do. You don't need a grid because we are just sketching the different functions that we have. So we're going to start with f of x equals x squared, and then times quantity of x plus 1 times quantity of x minus 3 to the power of 3 times quantity of x minus 5. So x squared, x plus 1, x minus 3, and x minus 5 are the factors that we have. Remember, factors are things you are multiplying together. So x squared is a factor, x plus 1 squared is a factor. And that means 0 is a 0, negative 1 is a 0, positive 3 is a 0, and 5 is a 0. So when we talk about factors, we're talking about that binomial that's being grouped together. When we talk about the zeros, we're talking about our x-intercepts. When we talk about multiplicity, it's the number of times that the function repeats that factor. So x minus 3 was to the power of 3, x minus 5 to the power of 1. So I'm going to go ahead, create a quick sketch. Our x-intercept in this, our y-intercept we know is going to be 0 because we have a point at x equals 0. I have a point at negative 1. I have a point at positive 3, and then I have another intercept at positive 5. Now, when we talk about the degree of this function, 2 plus 1 plus 3 is 6, plus another one is 7. My degree is 7. So when we talk about m behavior and that leading term being positive, we are going to increase as we approach positive infinity, decrease, or our function is heading towards negative infinity as we approach negative infinity in terms of x. Now at x squared, we have degree 2. So at x squared, we are going to have a bounce. Our function is going to touch the x-axis. And then at x minus 3 to the power of 3, we are going to have a swivel. Touched briefly about this in class on Friday. So when our function bounces, it touches the x-axis and bounces back up. You'll see it kind of looks like a mini parabola. Think about that being to the power of 2. X minus 3, we have a swivel. So the easiest way that I think about that is just that as it passes through the x-axis, we kind of want to make it look like a cubic function. Okay, I won't be super particular on your swivel, but I want to see that you know it doesn't cut through the axis like the function does here at positive 5. So multiplicities of 2, the function bounces. Multiplicity of 3 or anything that's odd, we're going to have a swivel, so it kind of looks like a cubic function as it passes through the graph. So we went over those sketches on Friday. Today we are going to do a couple of examples where you'll see that we don't have a function in factored form. Right now this is expanded. It's in standard form. The easiest way to graph higher degree polynomials is going to be to factor the function. So I can factor out a negative 3x squared. That's my greatest common factor. That would leave me then with x squared plus 2x. Sounds about right. Factor out negative 3x squared from 24x squared, and I am left with negative 8. Now, we can take this a little bit farther. Negative 3x squared, obviously, our greatest common factor stays the same, but this is quadratic. We can factor this to x plus 4 and x minus 2. So let's go ahead and talk about what our intercepts are going to be. X equals 0, x equals negative 4, x equals positive 2. So 1, 2, 3, 4, 1, 2, 3, 4. I have an intercept at 0, negative 4, positive 2. The degree of this function is a 4. It is even, and that leading coefficient is negative. Remember, if it's an even function, our m behavior has to match. The fact that it's negative, it goes down, down, even degree, just like a parabola. The arms go in the same direction. The only multiplicity I have that is not 1 is that power of 2 at 0. So that tells me I'm going to have a bounce here. It's going to cut through the intercepts everywhere else and just pass through the x-axis because those are a multiplicity of 1. I bounce off of my 0 and then pass back through positive 2. Remember, we're not super particular about y values here. We are sketching the graph, focusing on our end behavior, and then our bounces and swivels as we pass through the function. And then the last example I will do with you, looks like my notes are already saved from the last time I did this one. So we're going to go ahead and erase that. Pretend like you didn't see that. We'll erase. So I'll talk a little bit about this function as I'm erasing here. We have 4x cubed plus 8x squared minus x minus 2. Now, if you have 4 terms, and you'll see we don't have a greatest common factor, what I typically try and do first is that we are going to factor this function by grouping. So I'm going to group 4x cubed plus 8x squared. Group that. And then I'm going to have negative x and then a negative 2 in the second grouping. I always make sure I put the parentheses outside of that negative because I want to be able to pull out a negative coefficient when I look for that GCF. So factoring out a 4x squared, I am left with x plus 2. And if we factor out a negative 1, that being my common factor of the second group, I'm left with x plus 2. Now, if I put that negative with the x, that coefficient outside of the parentheses, we wouldn't have factored out a negative 1. Your quantities inside the parentheses would not have matched. X plus 2 is my common factor. And then if I factored out an x plus 2, what am I left with? I'm left with 4x squared minus 1. So far, so good. Recognizing this is difference of squares, we can factor it a little bit further. 2x plus 1, 2x minus 1. All right, now I've got my function fully in factored form. So let's talk about our zeros. We have negative 2, negative 1/2, positive 1/2. I'm going to go ahead and put some marks on my axis. We have negative 1/2, positive 1/2, and then I also have a negative 2. If we wanted to sketch, now that we don't have an intercept at 0, we do have a y-intercept. F of 0 for this function, those are all zeros. You're going to be left with negative 2. So I'll mark negative 2 down there on the y-axis. Make sure that I touch that point. That's really the only y value that we care about when we sketch this, is can I show where I cross the y-axis. My degree is odd. That leading coefficient is a positive 4. My hem behavior is down, up. It's increasing as we go towards positive infinity. Odd degree, the arms move in separate directions. All of these multiplicities are 1, so we are going to pass through all of our x-intercepts. No bounces, no swivels. Feel free to go back and rewatch this video. Pause, rewind as needed. Remember, multiplicity of 1, we're passing right through the axis. Multiplicity of 2, you'll see that's when we have our bounce. Multiplicity 2 at 0, bounce. And then multiplicity x squared, we have a bounce at 0. Multiplicity 3, we have a swivel. It looks like a cubic function as it goes through the axis. So today's learning target is that you guys are able to sketch a polynomial function, just like you were on Friday, except today, when the problems don't start in factored form, you are going to use your factoring strategies to find the zeros of that function. Have a great day and good luck with today's assignments.